Hi everybody, it's Professor Hickey here. A little surprised by how few of you took advantage of this opportunity, but I do have one question that was emailed to me, so I'll go ahead and take care of that right now. Christian Ruiz wanted to know a little bit more about bond order, and I'm willing to bet there are a few of you that have forgotten how that worked or what it even meant. And so the basic idea of bond order was that you were trying to kind of just put a numerical value on a type of covalent bond. And that's really straightforward if you're looking at a simple bond between two atoms. For example, a single bond like this would have a bond order of 1, whereas a double bond between a pair of oxygen atoms would have a bond order of 2, and a triple bond between a set of nitrogen atoms would have a bond order of 3. Now, where this came in handy was when we dealt with resonance, because in resonance structures, the true nature of the molecule is somewhere in between. It's not any one of the structures. It's most accurately the average of all 2 or 3 or potentially as many as 5 or 6 resonance structures when you get into organic chemistry. And so in order to really assess that and to say how strong we think a bond is going to be, one way of doing that is using bond order, because that gives us a number that we can actually average instead of trying to say, well, it's the average between this picture and that other picture. So the example I've put up here on the board is for carbonate. There's no reason specifically why this is any lower. It's just that I ran out of board space. At any rate, if I look at this and I want to ask myself for a certain CO bond, what is the bond order? What I'm looking at is 3 different structures where in one case, a given bond, let's say I want to look specifically at this one, that given bond is, in one case, the double bond. So here it would have a bond order of 2 in that particular Lewis structure. Here and here, it would have a bond order of 1. And so what I'm doing here is basically coming up with an average just from the numbers and saying that, well, if the right formula for this, or the right representation of this molecule is really an average of all 3 possibilities, then that means that the real bond order is the average of all 3 of those possible bond orders. So 1 plus 1 plus 2, and then since there are 3 structures, I'm dividing that by 3 to get my average. So the bond order ends up being 4/3 or 1 1/3. And if I look at any of the other specific bonds here, pull up some different colors maybe. If I look at any of the other specific bonds, what I'll find is that looking at this top guy, it is also a single bond twice and a double bond once. And if I look over at the one on the right side, I'll again see that it's a single bond twice and a double bond once. So in each of those cases, if I were to ask you on a test, what is the bond order of a CO bond in this molecule, your answer would be it's 1 1/3, which, remember, that means that it acts a little bit like a single bond, a little bit like a double bond. It's not quite as long and weak as a single bond, but it's also nowhere near as strong and short as a double bond would be. Hope that clears it up. Please excuse the getup. I'm going to do one more video that wasn't from one of your questions, but actually from something I noticed a lot of people struggling with on the chemical reactions lab. Be right back.